Welcome students. In this video lectures, I am going to continue the chapter 4. The name of the chapter is Determinant. Okay, here I am going to explain how to find the area of a triangle using the determinant method. So students, in the earlier classes, you have got how to find the area of triangle whose vertices are x1, y1, x2, y2 and x3, y3. And all of you know that the area of triangle having these vertices is equal to given by k equal to half x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So students, in order to find the area of triangle in determinant form, this formula can be written in terms of determinant, which is like this: delta equal to half x1 y x2 y x3 in the first column, in the second column y1 y2 y3, in the third column 1 1 and 1. So students, after arranging such type of determinant and after evaluating this, after expanding this determinant, you can find the area of triangle whose vertices are x1 y1, x2 y2 and x3 y3. So students, this is the expanded form of this determinant. If we expand this determinant, you will get this formula. So I hope all of you understood. Now there are some points you have to remember. Since area is a positive quantity, we always take the absolute value of determinant. Even if the value comes negative, we have to consider the positive value, because area is an absolute value, it is never a negative value. Second is, if area is given, use both positive and negative values of determinant for calculations. So students, the third point is the area of triangle formed by three collinear points is 0, because when three collinear points will be there, then there is no triangle formed by a three collinear points. So the area formed by these three collinear points will be 0. So students, I hope all of you understood the formula of area of triangle using determinant. So let us consider a few questions. The first question is, find the area of triangle with vertices at the point given in each of the following. So 3 points are given of a triangle. You have to find the area of triangle formed from this vertices using determinant. So this is the formula of using this determinant. The formula of determinant is half into x1, x2, x3. So first point is x1, y1, second point is x2, y2 and third point is x3, y3. So here x1 is 2 and x2 is 1, x3 is 10. So 2, 1, 10. y1 is 7, y2 is 1, y3 is 8. So 7, 1, 8 and the last column 1, 1, 1. So students, after writing this in determinant form, you have to expand it correctly. As I have explained in the previous video lectures, how to expand a 3 cross 3 determinant. Half, this is the formula, half into this is expanded along the row 1. So 2 into its minor 1 minus 8 minus 7 into 1 minus 10 plus 1 into 8 minus 10. So half 2 into minus 7 into minus 9, 1 into minus 2. So after calculating, its value becomes 47 by 2 square unit. So I hope students, all of you understood. The next question is show that the 3 points given are collinear, means they lies on the same line. So students, as I have explained, when 3 points are collinear, the area formed by these 3 points will be 0. So as we have to prove that these 3 points are collinear, so we need to find the area of triangle from these 3 points. If the area is 0, then it is proved that these 3 points are collinear. So students, let us start the area of triangle using determinant by these 3 points. How to find out? First you have to write x1, y1, x2, x1, x2, x3. So first point is x1, x2, x3, right? And then y1 is b plus c, y2 is c plus a, and y3 is a plus b. The last column is 1, 1, and 1. So students, here we can apply some properties of determinant so that you can reduce its numbers. Okay students, and we can easily expand and get the values. So what we have done it, applying R2 is changing by R2 minus R1, and R3 is changing by R3 minus R1. Keeping R1 fixed, going to change R2 and R3. So it determinant becomes like this. Okay students, b minus a, here c cancelled, a minus b, 1 minus 1 0, then c minus a, here b cancelled, a minus c, and 1 minus 0. Now this is in this determinant we can take common a minus b from the second row and c minus a from the third row. So first row is not taking common any element, so it is same, a, b plus c 1, a minus b is taken common, so here minus 1 will be there, a minus b 1, 0, here c minus a is common, so 1, a minus c, so minus 1, 0. Now students, applying another operations, R3 is going to change by R3 plus R2. So when you do like this, these elements will be 0, these elements will be 0, and these elements will be 0. So we see that all the elements in the R3 is 0. So students, it is one of the property that we know that in a particular determinant, if one of the element of any particular row or column is 0, then the value of the determinant is 0. So students, we can say that its value is 0, thus area of the triangle formed by the given 3 points is 0, hence the given points are collinear. So students, I hope all of you understood this question. Let us consider one more questions. You can see in the screen. Find the value of k. Find the value of k if the triangle formed is 4 square unit and the vertices are minus 2, 0, 0, 4 and 0, k. So students, we have to find the value of unknown k, and given that the area of the triangle formed by these 3 vertices is equal to 4 square unit. So students, let us start with the formula of area of triangle. We know that the formula is this one. Here we have to write half into, first point is x1, x2, x3. In first column, minus 2, 0, 0. In second column, y1, y2, y3. So 0, 4, k. And in the third column, 1, 1, 1. After expanding, half is fixed, minus 2 into 4 minus k, 0 into 1, 0 minus 0, and 1 into 0 minus 0. So these two is 0 and the first number is half into minus 2 into 4 minus k, and if this 2 get cancelled and if you replace it, it will be k minus 4. So students, the value of its determinant is given k minus 4, so that is area of this triangle is k minus 4 and is given plus minus 4. Area is given 4, so it is nothing but plus minus 4. So when k minus 4 equal to plus 4, when k minus 4 equal to minus 4, the value of k will be 0, and when k minus 4 equal to plus 4, then k equal to 8. So the possible values for k either 0 or 8. So I hope students you understood this. This is another questions. You can see, find the equation of the line joining the points 3, 1 and 9, 3 using determinants. So students, we have to find an equation passing through both this point 3, 1 and 9, 3. So in order to find the equation on the of the line, let us take another point on the same line passing through these 2 points, and that another point is taken x, y. So as this point P lies on the line joining these 2 points, hence these 3 points are collinear, lies on the same line, and so the area of the triangle formed by these 3 points will be 0. So let us take the point B pxy, and the given points are A 3, 1, B 9, 3. So P will be a point on the line joining the given points, and so A, B, P are collinear, and so the area of the triangle formed will be 0. This is the formula of the area of triangle. Half is the formula. x1 is 3, x2 is 9, and x3 is x. So 3, 9x. y1 is 1, y2 is 3, and y3 is y. So 1, 3y, 1, 1, 1. So students, after expanding it along the first row, half 3 into 3 minus y minus 1 into 9 minus x plus 1 into 9y minus 3x, and it will be a simple equation. We can see that the equation will be x minus 3y equal to 0, and the required equation of the line joining the points, given points 3, 1 and 9, 3 is x minus 3y equal to 0. So students, here I am ending my today's videos. I hope all of you understood how to find the area of triangle using determinant, and we have done few questions here. I hope all of you understood, and if you have any doubts, you can contact me. Thank you very much.